Students, here I am starting a new module in chemistry, that is a module 5, acid-base concepts. Before entering into the major portions in the module, let me discuss what all are the prerequisites that is given in the syllabus. So actually what is an acid means? We know that acid is a substance that actually produces in hydrogen ions when it dissolves in water. That means all acids contains hydrogen, and the hydrogen ions are produced are responsible for the properties of an acid. ഒരു ആസിഡ് എന്ന് പറയുമ്പോൾ ഒരു വാട്ടറിൽ നമ്മൾ ഡിസോൾവ് ചെയ്യുന്ന സമയത്ത് എച്ച് പ്ലസ് പ്രൊഡ്യൂസ് ചെയ്യുന്നു. അതല്ലെങ്കിൽ എല്ലാ ആസിഡ്സിലും എന്ത് കാണുന്നുണ്ട്? ഇറ്റ്സ് ഹൈഡ്രോജൻ ഇസ് സീൻ, ഓർ the hydrogen ions that is produced as a result is responsible for the properties of an acid. And here some examples for the common acids is given. Some man-made acids are hydrochloric acid HCl, H2SO4, and nitric acid, that is HNO3. And there are certain natural acids also. One example is an ethanoic acids, which is found in vinegar. And the properties of acids is very familiar for you, and the some of the properties are given here. Acids have a sour taste, and acids dissolve in water to form solution which conduct electricity. And third is the acids turn blue litmus paper into red. And the last one is the pH of an acidic solution or acid is less than 7. And there are many uses for the acids, and certain uses of certain acids is given here. The first acid is a sulfuric acid. The sulfuric acid is mainly used in the detergents or can be used as a car batteries. And the next is the ethanoic acid, that means a vinegar to preserve the food. It is mainly used in our homes. The next is adhesives, so for adhesives or it is glues. All for these two purposes ethanoic acid is mainly used. And next is a third one, that is a hydrochloric acid. The HCl can be used for cleaning metals or later processing. Okay, so these are some of the uses of acids. More than that, there are many other acids which can be used for the wide varieties of applications also. Then after that, let me discuss what is a strong acids and a weak acids. What a strong acid means? Actually, a strong acid means that breaks down completely in water and gives off many H plus ions. That means if a substance that is dissolved in water, that means it ionizes completely or it breakdowns completely and giving off many of the H plus ions that is present in it, and that type of substance is called as strong acids. Here you can see all these ions are breakdown, or it can be seen that is completely breakdown or ionized. That means the strong acids are assumed to dissociate. If it is an HCl, it totally converted into or totally ionized into the H plus and the Cl minus. If it is HNO3, it is also ionizing into the corresponding cations and anions. Here the strong acids are assumed to dissociate completely when in aqueous solution. That is all about the strong acid. Then what does a weak acid means? A weak acid means it only partially breaks down, or it gives off much less H plus than a strong acid. If I am taking a particular substance and it is dissolved in water and it is not completely dissociated in the water, then I can say that particular substance is a weak acid. Why? Just because that substance is not fully break down or not fully ionized or not fully dissociated. Such substances is called a weak acids. That means partial breakdown is taking place. Here you can see some of the ions, some of them are dissociated completely and other is kept there itself, or means slightly dissociated. Weak acid dissociate only slightly in aqueous solution, and the majority of the molecules remain undissociated. Here you can see the majority of the molecules here. That means all these are undissociated molecule. Only some of them, that means here, one is here, one is here, and one is here. A little bit of the ions is getting dissociated. So such type of substance which only undergoing a partial dissociation in aqueous solution, and that substance is called a weak acid. Then what does a base means? Actually, a base is any metal oxide or hydroxide, or a base is a substance that reacts with an acid to give salt and water only. We know that if an acid and bases combines together, it will give out a salt and water. Similarly, I can say that as acid plus a metal oxide or hydroxide. Base means it may be a metal oxide or hydroxide. It can give the corresponding products, that is a salt plus water. And the ionic equation for this this is always standard. That means an OH minus plus H plus, or the H plus plus OH minus is gives to the water. And here some common examples are given here. The sodium oxide is one of the example of the base, then zinc oxide, then the copper 2 oxide, then magnesium oxide, aluminum oxide, then potassium hydroxide, means magnesium hydroxide, aluminum hydroxide, then potassium hydroxide, sodium, then many other examples are for the bases. And the family of the bases is having a certain classification. I will show you the family of bases. A little bit changes is here. Okay. The family of bases. The base can be classified into soluble and insoluble bases. The soluble bases are generally called the alkalis or alkalis, and the insoluble can be called the metal oxides and hydroxides. Anyway, what is an alkali means? So that from this classification, I can conclude that an alkali is a base that is soluble in water. Okay, so actually alkali means it is a base which is soluble in water. And some examples for the alkalis are called the sodium hydroxide, NaOH, potassium hydroxide, then calcium hydroxide, barium hydroxide, and also the aqueous ammonia. And what are the properties of alkali? As I discussed the properties of the acid, there are certain properties for the alkalis too. The alkalis have a bitter taste and the soapy feel. And after that, an alkali turns red litmus to blue, means paper into blue. And the pH value will be definitely greater than 7. We know that for an acid it is less than 7, and for the alkali it will be greater than 7. And all alkalis produce hydroxide ions, that means OH minus ion, when dissolved in water. But in the case of acid, we know that as it dissolves in water, it produces an H plus ion. But in the cases of alkali, we know that it produces an OH minus ion when it dissolves in water. And after that, what will happen if a sodium hydroxide is reacted with water? Definitely, or sodium hydroxide when dissolved in water, what it forms? It forms a sodium ion and a hydroxide ion. That means NaOH plus water definitely will give an Na plus plus OH minus. All alkalis react with acids to form salt and water only, and this is known as a neutralization reaction. The salt depends on the acid used. The salt that is produced depends upon the acid used. If a sulfuric acid is used, then the corresponding acid produced is a sulfide. If the hydrochloric acid is used, then the corresponding salt will be chlorides. Then after that, what all are the uses of alkali, which is similar to that of I discussed you earlier, that means the uses of acids. What all are the uses of alkalis? The ammonia solution is one of the example for alkali. It can be used for the veto cleaning solutions. That means the majority of the veto cleaning solutions will containing an emulsion solution. Okay. The next is the calcium oxide, which is an alkali, and it can be used to make iron, concrete, cement, etc. Then next is the magnesium hydroxide. Mainly our toothpaste is consisting of the magnesium hydroxide to neutralize teeth to means acid to teeth, in antacids to relieve indigestion. And the sodium hydroxide is used in making soaps and detergents. And here I given the pH values of this acidic solution, neutral solution, and the basic solution. We know that for an acidic solution, pH will be less than 7, and for the basic solution, pH will be greater than 7. Then so therefore we can conclude that what will be the pH for the neutral solution? Neutral solution means pH will be equal to 7. And it is represented as like this. This is a pH scale, and the values given here is the pH values. If it is 7, then we can call it as a neutral solution. If it is ranging from 0 to 7 or less than 7, we can call that region is called the acidic region. And if it is ranging from above 7 to 14, we can call that solution is an alkali solution. So what is here I given is a certain character, means certain difference between the acids and bases, or the some properties of acids and bases in a tabular manner. Acid means takes taste as a sour, and here it is a bitter taste. And acid do not feel slippery, but base feel slippery. Then pH is less than 7. Here base's pH is greater than 1. We know that acids mean it consisting of an H plus ion when it is dissolved in a water or an aqueous solution. But in the case of bases, it produces an OH minus. Then acids, due to the presence of acid, the metal may undergo corrosion or corrode. But in the presence of bases, the metal do not corrode. Then after that, then acid, it reacts with metal to produce a compound and a hydrogen gas, which is a very important reaction. But in the case of a base, do not react with the metals to produce a compound and a hydrogen gas. Then last point, and which is very important, which is used for the majority of the test in order to find out whether the particular substance is an acid or base, that is the turn litmus red to pink in the case of an acid. If it is a base, it turns litmus blue. So these are the basic concepts of an acids and bases, and after that I am discussing the concepts of acids and bases. So from here onwards we are entering into the major portions related to the acids and bases. We know that there are certain there are many concepts related to the acids and bases, and from that the first one is an Arrhenius theory of acids and bases, and there are many other concepts also. I will say one by one. That means Arrhenius theory of acids and bases, and after that I think Bronsted-Lowry concept, and after that Lex-Flood definition, then solvent system definition, then Lewis concepts, Usenovich concepts, and etc. and so on. Okay, so first I am going to discuss this an Arrhenius theory of an acids and bases, which is very familiar for you, and it is discussed or it was proposed in 1887, which by the Swedish chemist Avante Arrhenius proposed a new way of defining and thinking about an acid and bases. Before that, they don't know which substance will act as an acid or which substance will act as a base. From here onwards, from 1887 onwards, they propose that certain substance, if it produces an H plus ion, it will act as an acid. And if a certain substance which produces OH minus ion when dissolved in water, then they will act as a base. So according to Arrhenius concept, acids can be called as hydrogen containing compounds that ionize to yield an H plus ions in solution. But in the case of a base, Arrhenius concluded that bases are compounds that ionize to yield hydroxide ions in aqueous solution. According to him, acids are substances that produces H plus ions, and bases are substances that produces OH minus when both they are in an aqueous solution. So what does an Arrhenius acid means? Okay, so this is the basic concept of the Arrhenius. Then here I am explaining Arrhenius acids and Arrhenius bases. So what does an Arrhenius acid means? Acid vary in number of hydrogen they contain, and they can form hydrogen ions. We know that there are several hydrogens. Hydrochloric acid, which consisting of an HCl. Nitric acid is an HNO3. Sulfuric acid is H2SO4. It consisting of the 2 hydrogen. The phosphoric acid, which consisting of the 3 hydrogen. It means H3PO4. And ethanoic acid, mainly it consisting of CH3COOH. But we don't know that. First of all, we don't know that which hydrogen represents the presence of an acid. Carbonic acid, that consisting H2CO3. So generally I can say that acids may consisting of only 1 hydrogen, 2 hydrogen, or more than 2 hydrogen. So a hydrogen atom that can form a hydrogen ion is described as ionizable. If a hydrogen atom that is consisting in a substance, and if it produces a hydrogen ion, then that is called an ionizable. So nitric acid consisting of, that means HNO3 consisting of 1 ionizable hydrogen. That means the nitric acid ionized into H plus and NO3. Therefore, if it consisting of an 1 hydrogen, then I can say that it is a monoprotic acid. That means it consisting only 1 H in each. Okay. The prefix mono means actually 1, and the stem protic reflects that the fact a hydrogen ion is in a proton. Therefore, what will be the condition for the sulfuric acid? As in the case of the nitric acid, HNO3 consisting only 1 ionizable hydrogen. Therefore, I can say that it is a monoprotic acid. But in the case of the sulfuric acid, that means H2SO4, it consisting of the 2 ionizable hydrogens. And therefore, I can say that it is diprotic acid. But in the case of the phosphoric acid, which is represented as H3PO4, it is consisting of a 3 ionizable hydrogen. That means it can ionize the 3 hydrogen from this phosphoric acid. First of all, I can ionize. The ionization can be, or ionization will be represented like this: H plus PO4 minus. First, so H plus H2 PO4 minus. First of all, the second is H2 PO4 minus gives what? H plus HPO4 2 minus. Okay, that is a condition in which how the phosphoric acid is ionized. Anyway, phosphoric acid consisting of the 3 ionizable hydrogen, therefore called the triprotic acid. And we can see that not all compounds that contain hydrogens are acids. There are certain other compounds also which or certain other substances also which consisting of a hydrogen, but still it is not an acid. Therefore, we cannot conclude that all compounds that containing hydrogens are acid. There are certain exceptions are given to this concepts of this or the Arrhenius concepts. Only hydrogen that is bonded to a very electronegative element can be released as an ion. All the hydrogen cannot be ionized. If only the hydrogen that is bonded to a very electronegative element, such hydrogen can only ionized, and or such hydrogen can only released as an ion, and such bonds are highly polar also. When a compound that contains such bonds dissolves in water, it releases a hydrogen ion. Therefore, I will explain here with an example. When a HCl and it is connected to the high electronegative atom, here it is called high electronegative element Cl, then if it is in the presence of H2O, it changes into H plus plus Cl minus. That means hydrogen ion plus chloride ion. And you note one thing, that in an aqueous solution, the hydrogen ions are not present. Instead, the hydronium ions are joined to water molecules as hydronium ions. Hydronium ion means H3O plus. Is the ion that forms when a water molecule gains a hydrogen. H3O plus means if HCl is dissolved in water, what will happen? We know that the HCl is dissociated into H plus and Cl minus. And that H plus, here this H plus is reacted with H2O to form an H3O plus. And that H3O plus is called the hydronium ion, and the other Cl minus is a chloride ion. So if HCl is dissolved in water, what will form? The HCl first of all ionized into H plus and Cl minus, and that H plus combines with the H2O and gives an hydronium ion, that is H3O plus ions and the chloride ion. But in the case of methane, here methane is also an example of a hydrogen containing compound, but it is not an acid. Why? Here the 4 hydrogen atoms in methane are attached to the central carbon atom by a weakly polar carbon hydrogen bonds. Here one atom is not related or not attached to the highly electronegative element. A carbon is attached to the hydrogen. Therefore, we can say that it is a weakly polar bonds. Methane has no ionizable hydrogen and is not an acid. If a compound has an ionizable hydrogen only if it is connected to a highly electronegative element. But in the case of methane, the carbon is connected to a hydrogen and the bond is weakly polar. Therefore, the methane has no ionizable hydrogen and can called as it is and cannot be represented as a acid. Then next is ethanoic acid. Ethanoic acid in another example CH3COH, or it is called acetic acid. Then it is an example of a molecule contain both hydrogen that do not ionize and a hydrogen that does ionize. Here 3 hydrogen is here and 1 hydrogen is here. But this 3 hydrogen cannot be ionized and this single hydrogen is ionized. Even though the ethanoic acid consisting of the 4 hydrogen and the 3 is shown here, this 3 hydrogen cannot be ionized, and here is 1 hydrogen is here and this hydrogen can be ionized. Therefore, it consisting only the 1 ionized hydrogen, and so called the ethanoic acid is a monoprotic acid. Here the carbon is attached to the 3 hydrogen and here the oxygen is attached to the hydrogen. Therefore, I can say that this is the only, that means the hydrogen is connected to the oxygen. So this hydrogen will getting ionized. Therefore, I can say that ethanoic acid is a monoprotic acid. The explanation is given here. The 3 hydrogen attached to the carbon atom are weakly polar. We know that these 3 hydrogens are weakly polar. Why? Is because a large difference in the electronegativities is not seen in between them, and they do not ionized. If the bond is weakly polar, then we know that they do not ionize. Only the hydrogen bonded to highly electronegative oxygen can be ionized. Here the ionized hydrogen is shown here. That is, the hydrogen is connected to the highly electronegative oxygen. Then one question is arised. Can every hydrogen from every molecule form hydrogen ions, therefore acting as an Arrhenius acid? No, it is not at all practically possible. That means only hydrogens that are bonded to a very electronegative element can be released as an ions. If a particular hydrogen is not attached to the highly electronegative element, then it cannot be released as an ion or it cannot be ionized. That means that only molecules containing hydrogen bonded to very electronegative elements are Arrhenius acids, and all other acids cannot be considered as an Arrhenius acids. Then what is a strong and weak acid? I already discussed you what is a strong acid and weak acid. Strong means which is ionized completely. Weak means ionized partially. Okay. Here HCl is given here. H2O in the presence of H2O it gives H plus and Cl minus. As it is an acidic solution, the concentration of H plus ion will getting increases. Here what is a strong acid means? Here one diagram is given here. So this is an H plus and this is a Cl minus. If you counter this, you can see 1, 2, 3, 4 and 5. 5 H plus is here and 1, 2, 3, 4 and 5. 5 Cl minus is also here. So what is a strong acid means? A strong acid is a water soluble compound that completely dissociated to give H3O plus ions. Here the condition is that the compound that here the condition is that the strong acid is a water soluble compound. The next is the weak acid, H2CO3. A weak acid is actually a water, it is also a water soluble substance that dissociated only partially. Therefore, all the H2CO3 is not ionized. Only a little bit of the H2CO3 is ionized, producing a few H3O plus. Here the HCO3 minus is here. Okay, so this is ionized. And all others are same acid, same itself, H2CO3. Okay, the next is Arrhenius bases. So up to here we discuss what is an Arrhenius acid. You just go through it. And what is an Arrhenius base means? We know that bases are substances that produce hydroxide ions, that is OH minus when dissolved in water. That is NaOH changes into Na plus plus OH minus. And some common bases are given here. Sodium hydroxide means NaOH, and solubility in water means if it is taken in a water whether it is soluble or not. It is high soluble. Potassium hydroxide, it is also high soluble. Calcium hydroxide, which is a very low solubility in calcium hydroxide, and the magnesium hydroxide, it is also having a very low solubility in water. And one point is given here: any compound that contain a metal and hydroxide ion group, hydroxide group produces OH minus hydroxide ions when dissolved in water. Basically, I can say that substances that produce hydroxide ions are called bases, or substances then OH minus when dissolved in water, then NaOH plus Na plus plus OH minus. Since the Arrhenius concept is a very important concept, it consisting of certain limitations also. The limitations of the Arrhenius theory are H plus do not exist in solution as H3O plus. Then more likely to find H plus attached to water. The next limitation is that more bases or some bases like ammonia do not fit in this solution. That means that ammonia doesn't have an H plus when it dissolves in water. The solution is basic, but the compound does not dissociate, forming hydroxide ion. Okay, limited to solvent system, but give acid-base reaction can occur in other solvents. The third limitation is explained again. Some bases like ammonia do not fit this definition. The solution is basic, but the compound does not dissociate, forming hydroxide ion. Actually, ammonia is a base, but it does not give an hydroxide ion when it dissociated in water. Therefore, we can say that the definition, the Arrhenius definition, is not applicable to the compound like ammonia. Therefore, we can say that it is one of the limitations of this Arrhenius theory also. Next is limited to the solvent water, but acid-base reaction can occur in other solvent. There are many there are different solvents can be used in chemistry, but water is only a solvent. Water is only one of the solvent that is used. But in the case of other solvents, there are other solvents in which the acid-base reaction can occur. For other solvents, the theory or the Arrhenius theory is not applicable. The fifth limitation is that it could not explain the acidic and basic nature of compounds having no tendency to loss or gain H plus ions. There are several other compounds which does not have the tendency to loss or gain H plus ion. But as in the case of the Arrhenius, they are explaining a substance as an acid or basis on the basis of the tendency to loss or gain of H plus ion. Therefore, compounds like CO2, NH3, SO2, SO3, etc., they cannot find out, or they cannot find out whether it is an acid or basic nature. Therefore, it will be also one of the limitation of the Arrhenius theory. So in order to overcome the limitations of this Arrhenius theory, Bronsted and Lowry, that means the two scientists, propose in another definition or another concept for the acids and bases. So we can discuss what is the Bronsted-Lowry concept of acids and bases. What is Bronsted-Lowry acids and bases?